Good day to the Honorable Judges. Let me introduce myself. My name is Asok Kumar and I am from UOWKD University, and for today I am going to present my final year project, which is known as Numerical Analysis of Debonding Behavior of High Performance Concrete, Strengthened Reinforced Concrete RCB. Let's move on to the introduction. Reinforced Concrete RCB is a dynamic composite that is widely used in a model structure, while high-performance concrete frequently contains silica fumes, which normal concrete did not have that kind of substance. Let's move on to the objective of this research. For the first objective is to develop a finite element model to predict debonding behavior of HPC layer on RC cantilever beam. The second objective is to evaluate the influence of three major parameters, which is known as thickness, effective width, and friction coefficient. And the final objective is to formulate predictive equation using multiple linear regression analysis as a debonding failure prediction tool. As you can see, this is the model of high performance concrete, strengthened reinforced concrete. The blue color structure is known as reinforced concrete and the green color layer is known for high performance concrete, which was assembled by using Abacus software. So the total of 37,860 kN force was applied on the top of HPC layer. After the simulation was done, the result was produced. For the first result, which is corresponding to the first objective, showing that results of bone mixture stress, shear stress, and load and displacement for the model with HPC and the model without HPC. So from these three graphs, we can summarize that the model with HPC contributes less bone mixture stress, shear stress, and displacement compared to model without HPC, and it is proven that model with HPC contributes less stress and less work that prevent debonding from happening. Let's move on to the second result, which is corresponding to the second objective, which is the influence of three major parameters. So for the first one, which is the effect of thickness, that ranges between 20 mm to 40 mm. So from these three graphs, which is contact open, bone mixture stress, and shear stress, we can summarize that thicker high performance concrete contributes to less bone mixture stress and shear stress, while thinner high performance concrete contributes to higher contact open, since thin layer can easily come out of another material. Let's move on to the effect of friction coefficient. From these three graphs, we can summarize that smaller coefficient of friction contribute to less shear stress and less bone mixture stress due to smoothness interface between reinforced concrete and HPC layer, while higher coefficient of friction contributes to less contact open due to rougher interface between HPC layer and reinforced concrete. So let's move on to the effect of effective width, and from these three graphs we can summarize that greater effective width does contribute to lower contact open, since the larger surface area HPC restrict contact open from happening. Moreover, smaller effective width of high performance concrete layer produces less bone mixture stress and shear stress due to smaller surface area of effective width. Let's move on to the final result, which is corresponding to the final objective, which is the formulation of predictive equation of multiple linear regression. This multiple linear regression equation was formulated by simulating all 36 models of high performance concrete, strengthened reinforced concrete, and all maximum value of contact open, shear stress, and bone mixture stress was taken, and the multiple linear regression analysis was run and the predictive equation was formulated. In order to verify this equation, the condition has to be met. So the value of R square need to be nearer to 1, while the value of significant F and P value need to be less than 0.05. Since the condition has been met, so the predictive equation was finalized and the fast debonding failure prediction tool was formulated. So as you can see, overall all the objective was achieved for this research. And finally, the importance of this research is that if engineers, mainly in civil industry, experiencing debonding behavior, they do not have to do the simulation. By the way, they can straight away take this predictive equation to overcome the debonding failure. That's all from me. Thank you.